Sindi mtima umo. Tiende pambo sindi mtima umo. Tiende pambo sindi mtima umo. Tiende pambo sindi mtima umo.
Hello guys, welcome to MTN Teleschool and thank you so much for tuning in. My name is By Kasonde from Kafiwa Boys Secondary School. I'm a specialist in mathematics education. Today we are looking at revision of Mathematics 2017 and this one is in this session we'll specifically look at Mathematics paper 2. Okay, we'll look at Mathematics paper 2. So I've taken note of a few comments from our friends on Facebook. I will respond to you as soon as possible. All right, so in the last session for today, which is this session, let's start with question number 9. We start with question number 9 from 2017 Mathematics paper 2. Question number 9. All right, so question number 9. The question is W, X, Y and Z are 4 points on the surface of the earth as shown in the diagram below. Take pi as 3.142 and r equal to 3,437 nautical miles. So when you look at this question, the question is from the topic called Earth geometry. Okay, and so when we look at the diagram that we are given, we have the structure of the earth. Okay, then we have two longitudes. We have latitude 80 degrees north. This is the North Pole, and we have the South Pole. This is longitude 105 degrees east, and we have longitude 15 degrees west. Then we have longitude 30 degrees south, and on longitude 30 degrees south we have 2 points. We have point Y, point Z, and on longitude 80 degrees north we have point W and point X. So when you look at point W is on latitude 80 degrees north and longitude 15 degrees west. Point X is 80 degrees north and 105 degrees east. Point Y is 30 degrees south and 15 degrees west, on longitude 15 degrees west. And our last point Z is on latitude 30 degrees south and longitude 105 east. 105 degrees east. All right, so when we look at the diagram here, the first question that we have to answer is the difference in latitude between W and Y. Difference in latitude between W and Y. So as you can see, the points W and Y are on the same longitude, and that is longitude 15 degrees west. But these 2 points are on 2 different latitudes that are in 2 different hemispheres. So we have the point W is on latitude 80 degrees north, and point y is on latitude 30 degrees south. So how do we find the angular distance of 2 points in different hemispheres? We simply add the angles. So finding the angular distance, which is question number 1, 9A1, the angular distance between W and Y will be given by theta, which will be equal to 80, which is the latitude where W is, which is 80 degrees, plus 30 degrees, like that. So you have to bear in mind that when you have 2 points on 2 different hemispheres, then the angles or the latitudes will add. When you have 2 points in the same hemisphere, then you subtract. So in this case, we have 1 point in the southern hemisphere, the other one in the northern part of the equator, which is the upper part of the equator. So what we are going to do is simply add. And when you add 80 plus 30, we get 110 degrees. So this is the angular distance between W and Y. So that is how you find the difference in latitude. The difference in latitude is simply the angular distance between the 2 points. Okay, so we answer question number 2. Question number 2, calculate the distance in nautical miles between X and Y. Distance in nautical miles between X and Z along latitude 105, along longitude 105. So as you can see, we have the longitude 105, which is this longitude. This is longitude 105, and we have the center of the Earth somewhere there. So we are looking for the distance between X and Z, which is the distance between X and Z, which is this distance there. So when I connect this point to the radius and I connect that point to the radius, we have theta on the middle of that, which is just on the center of the Earth. That is what we have, and this angle, it is the angular distance that is subtended by an arc, which is the distance from X and Y. So the angular distance, we can see that the distance from X and Y, it is actually the difference in latitude. So the angular distance, which is the angle subtended by the arc XY on the center of the Earth, will be given by the angular distance, or the difference in latitude between W and Z, between X and Z. As you can see, the angular distance between W and Y is the same angular distance between X and Z, because these are on the same latitude. Okay, they are on the same latitude. So we found the difference in latitude. So since they are on the same latitudes, then we have to just use the same angular distance. So when you calculate the angular distance for point X and Z, you still have the same angular distance between W and Y, which is the difference in latitude. So when you get the angular distance, in this case we have calculated angular distance as 110. We are calculating for the distance of X and Y, or the distance in nautical miles between X and Y. So drawing this arc, it will look like we have that. So this will be point X and this will be point Z. Then we have our angular distance, which in this case is 110. So we find the distance between x and z, which is arc length. So how do you find arc length? So what we are saying is that the distance between x and z, so xz, which is the distance, will be given by theta over 360 multiplied by 2 pi r, multiplied by 2 pi r. So I'm using capital R because when you look at lines of longitudes are great circles. So the radius of this arc will be the radius of the earth, which is capital R, because this arc is from a great circle, it's from a longitude. So I'm using capital R. So our angular distance in this case will be 110 divided by 360 times 2. Our pi is 3.142. Then you have our radius of the earth in nautical miles is 3437 nautical miles, like that. So when you simplify this, you multiply, you will get the distance as 6599.42 nautical miles. So this is the distance between x and z. So you can verify the answer. This is mathematics paper 2. You are allowed to use a calc, so you can verify the answer by simply multiplying the terms that we have there. So this is the angular distance between x and z. All right, so we go to B of 9.2, part B of 9.2. Right, so here we are asked to calculate the distance in nautical miles between y and z. Distance in nautical miles between y and z. Between y, which is this point, and z, which is that point. So you realize that latitude 30 degrees south is not a great circle. So we have the center of this minor circle, and when I connect the point y to the center of the minor circle, and another point when I connect the point z to the center, which is the origin, or which is the center of the circle, the minor circle having latitude 30 degrees, you see that we will have an arc like that, which is y, and z will have theta there, which is the angular distance. So it is the same concept, but here we are dealing with radius of a minor circle and not radius of a great circle. So how do we find the distance? We use the same formula, which is yz will be equal to theta over 360 multiplied by 2 pi r. So I'm using small letter r because I'm dealing with the radius of a minor circle. All right, so we also have to bear in mind that radius of a minor circle is given by capital R, which is radius of the earth, then cosine theta, where this theta is the angle of a given latitude. All right, so we'll have y will be equal to the angular distance between y and z. We can see that y is on latitude, is on latitude 30 but on longitude 15 degrees west. Z is on latitude 30 degrees south and longitude 105 degrees east. So we'll find angular distance in longitude between y and z, and so since they are in two different hemispheres, we are going to add, okay, we are going to add. So we'll find theta will be equal to, so we have 105 degrees plus 15 degrees, and this will give us 120 degrees. So then YZ will be equal to 120 degrees divided by 360 degrees multiplied by 2. Our pi is 3.142, and our radius, where there is r, here I will substitute by r cos theta. So the radius of the earth in nautical miles is 3437 nautical miles. Then I'm multiplying this by cosine 30 degrees because it's on latitude 30. So I'm multiplying by cos 30. Okay. Alright, so simplifying this, we are going to have 120 divided by 360 degrees multiplied by 3.142, and then 3,437 nautical miles multiplied by cos 30 will give us 2,976.529,313, and simplifying this will give us 3241.12 nautical miles. Right. So this is how you find the distance of an arc along the great circle and also on a minor circle. So you have to be very careful as you are finding distance of 2 points on a minor circle. Why? Because the small radius is equal to r cos theta as the small radius. So you have to be very careful and take note of the radii or difference in radii. Okay. So we quickly go to question number 9, part B. Question number 9, part B. Question number 9, part B. We are asked to find the coordinates of the points on the curve. Y is equal to 2x cubed minus 3x squared minus 36x minus 3. All right. So when you look at this function, which is y is equal to 2x cubed minus 3x squared minus 36x minus 3, this function is a cubic function, and in this case they want us to find the coordinates of the point on the curve where gradient is equal to 0. So when given such a function, we can use methods of calculus. Okay, we can actually use the concept of a stationary point in calculus. So we know that at a stationary point, gradient is equal to 0. So what are we supposed to do? First of all, we need to differentiate the function y so that we get the gradient function. So then when we get the gradient function, then we know that at a stationary point, gradient is equal to 0. Then our gradient function is supposed to be equated to 0. Then we find the values of x, or we find the x-intercepts, and then we can now find the values of y as well. So let's look at this question and see how we can find the coordinates of the point where gradient is equal to 0 when we are given this function. All right. So the first thing that we need to do, which is step 1, step number 1, we first of all differentiate the function y. So we'll find the derivative of the function y, which is differentiating y with respect to x. So this will give us 6x squared minus minus 6x minus 36. We call this as star 1. How did I do that? Okay. So when you are given a function y is equal to x raised to the power n, then differentiating the function y in this case will be dy dx will be equal to, now the coefficient of x, which is 1 here, will be multiplied by n. So we'll have n, x, and the power n will be subtracted by 1. When you are given the function y is equal to n x raised to the power n, where a is the coefficient of x, then the derivative of the function y will be equal to an xn raised to the power 1. So basically that is what I did. So this method or this process is the same process actually I used to find the derivatives of these terms, okay, of this term. So I multiplied the 3 by 2, which is as good as multiplying n by a. So you get 6, then the power you subtract it by 1. So that is how you differentiate. All right. So now that we have our gradient function, which is y prime or dy dx, or the derivative of y with respect to x, as 6x squared minus 6x minus 36, then at stationary point gradient is equal to 0. So what we have, this is a gradient function, okay? So what we have is that we have to equate our gradient function, which is 6x squared minus 6x minus 36 equal to 0, because we know that at stationary point gradient is equal to 0. So when you do that, then you realize that this is a quadratic function, so we can quickly work it out. So I will reduce. When I factor out 6, I will have 6x squared minus x, then minus 6 equal to 0, which gives me x minus 6 equal to 0 when you divide both sides of this equation by positive 6. So we have the equation x squared minus x minus 6. So this is a quadratic function or a quadratic expression. So how can we find now the coordinates or the values of x? So solving quadratic expressions, you can use different methods. You can use a factorization method, you can also use completing of the square method, and you can use graphical method. Okay, so I'm going to use factorization method. So how do you use factorization method? Well, the general definition of a quadratic expression is that this is an expression which is in form of ax squared plus bx plus c is equal to 0, where a, b, and c are constants and a is not equal to 0. So the first thing that you do is that you identify a, the value of a. So in this case, from our star 1, the value of a is 1, which is the coefficient of x squared. The value of b is negative 1, which is the coefficient of x. And the value of c is negative 6, which is a constant. So what you need to do is that you find the product of a and c. So the product of a and c, which is a times c, will give us 1 times negative 6, which will give us negative 6. Then what you need to do is that you need to look for factors of 6, of which when you add them, you get the coefficient of x, but when you multiply them, you get the product of a and c. Or when you actually multiply them, you get c, okay, you get c, but when you add them, you get the coefficient of x, which is b. Okay, so when we look at star 1, which is our equation star 1, we have x squared minus x minus 6 is equal to 0. So the product of a and c will give us negative 6. The factors of 6 that can be added, two factors of 6, we have 2 and 3. These are the factors of 6 that can be multiplied to give us 6. So then, you have a 3 there. So these are the two factors of 6 that can be multiplied to give us 6, which is the product of a and c. Now, what we are going to do is that we'll assign signs in such a way that when we add these, we'll get a negative 1, which is the coefficient of x. So we can only get the coefficient of x negative 1 if 2 is positive and 3 is negative. So rewriting this expression in terms of the factors of 6, we are going to have x squared minus 3x plus 2x minus 6 is equal to 0. Then we can say x squared minus 3x, then plus 2x minus 6, 0. Then we factor out x from this term, so we have x, you have x minus 3. Then we find the common factor on this term, which is 2. Then positive, this positive times this negative here will get, so what will happen is that when you factor out a 2, when you divide this 2 into the term 2x, you remain with x. Then the positive multiplied by the negative there, you get minus. Then 2 into 6, this 6, you get 3, then equal to 0. So this can also be written as x plus 2. You get the terms outside the bracket, but then you realize that the term inside the bracket here is equal to the other term, so we just pick one term, so you have x minus 3 is equal to 0. So by implication, either x plus 2 is equal to 0 or x minus 3 is equal to 0. So solving for x, we'll say that the value of x is equal to negative 2, or value of x will be equal to positive 3. Now that you have the values of x, we are looking for the coordinates of the point. So what you need to do is that you now need to substitute the values of x into the function y, which is the original function, in order for you to get the coordinates of y. So our original function is y is equal to 2x cubed minus 3x squared minus 36x minus 3. So at the point x is equal to negative 2, which is this value, we are going to have the value of y equal to 2 negative 2 cubed minus 3 negative 2 squared minus 36 negative 2 minus 3, like that. So this will give us 2, then negative 2 raised to the power 3, you get minus 8. Then minus 3, negative 2 raised to the power 2, you get positive 4, minus 36 minus 2 minus 3. So multiplying 2 by negative 8, you get minus 16. Then minus 3 by 4, you get minus 12. Then minus 36 multiplied by minus 2, you get positive 72. You get positive 72. Then minus 3. And so when you simplify this, you realize that you get positive 41. Therefore, the first coordinate is negative 2 comma 41 as our first coordinate. So doing the same thing at the point where x is equal to positive 3, at a point where x is equal to positive 3, it means that we'll have y, then substituting into the original equation, which is this equation, okay, then we'll get y is equal to 2 raised to the power 3 cubed minus 3 raised to the power 3 squared minus 36 multiplied by 3, then minus 3. Then simplifying this will give us minus 84. Therefore, the two coordinates that we need, or the two coordinates of the points actually on the curve where the gradient is equal to 0, will be, the first point will be minus 2 comma 41 and 3 comma negative 84. So guys, that is how you solve this particular question, which is question B. Now before I look at question number 9, let's take a quick break. We'll soon be back and look at question number 9.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama nizingono, or nizambili,
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tiloa.
Cause cash money yeve across Zambia.
Tituma. Ati? At Basi and Kuchpat. End of South Africa. Hello, what?
Run, K-Star, run!
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma. MTN.
Tiende pamozi ni mtima umo.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama nizingono, or nizambili,
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tiloa.
Cause cash money yeve across Zambia.
Tituma. Ati? At Basi and Kuchpat. End of South Africa. Hello, what?
Run, K-Star, run!
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN, everywhere you go.
Do you expect more from your internet service? Maybe it's time to switch to MTN's 4G internet. Introducing the next level in high-performance mobile network technology, taking your home or office internet experience to a whole new level while keeping it simple. Get to work by the click of a button or manage your team from miles away. Browse faster, download multiple files, and stream videos quicker with no limits. Get it all done with MTN's 4G internet. So don't let your internet slow you down. Stay online in real time all the time. Get your MTN 4G SIM today and find your nearest 4G zone to enjoy maximum performance of your 4G enabled device. MTN, everywhere you go.
Alright guys, welcome back. Before the break, we were looking at question number 9 from 2017 Mathematics Paper 2. In case you just joined us, this is MTN Teleschool. If you have questions and comments, simply like our page on Facebook, MTN Zambia, and drop your comment. I will be able to look at it. You can as well download our app from Google Play Store, which is MTN TV Plus, and watch all the lessons for free. So let's go back to our lesson and look at question number 9C. Question number 9C. All right, so question number 9C. Evaluate the integral of 3x squared minus 2x dx from 3 to negative 1 as limits. So when you look at this integral, this is a definite integral. And definite integrals are used to determine the area under a given curve. All right. So how can we answer this question? So before I answer the question, I'll just go through the general rule of integration, which is anti-differentiation. So when you are given a function, let's say you are given a function y is equal to x squared. Okay? And now you want to integrate this function x squared with respect to x. It simply means that integrating the function x squared, what we'll be doing is that the integral will have x, then the power will be added by 1, then divided by the power, which is 2 plus 1. Then since this is an indefinite integral, you add the constant of integration. But when you are given the function y is equal to xn, and this function x raised to the power n is being integrated from b to a, then it means that the integral of x raised to the power n will be x n plus 1 over n plus 1 from the limit a to b, and limit a to b simply means that we are going to have b n plus 1 over n plus 1, then minus a n plus 1 over n plus 1. All right. So getting back to our question, we have the integral of 3 negative 1 3x squared minus 2x dx. So the first thing we do is to integrate the function 3x raised to the power 2 minus 2x with respect to x. So integrating that function will give us 3x 2 plus 1 over 2 plus 1 minus 2x1 plus 1 over 1 plus 1 from the limits negative 1 to positive 3. So simplifying this, we'll have 3x cubed over 3 minus 2x squared over 2 from 3 to negative 1. Then this will give us x cubed minus x squared 3 from 3 to negative 1. All right. Then this means that we have 3 raised to the power 3 minus 3 raised to the power 2, then minus negative 1 raised to the power positive 3, then minus negative 1 raised to the power 2. So 3 raised to the power 3, we get 27. We are multiplying 3 times by itself, we get 27. Then 3 raised to the power 2, we get 9. Then minus negative 1 raised to the power 3, we get negative 1. Then negative 1 raised to the power 2, that is positive 1, multiplied by negative 1, we get positive 1. So this term will be equal to 0. This term will become 0 because minus 1 positive 1 is equal to 0. So 27 minus 9 will get 18 minus 0. Then we get 18 square units as the integral. So this is the area under the curve, which is 18 square units, or it is the value of the integral. So that is how you answer this question, guys. Just in case you have problems, simply leave the comment on our Facebook page. I can see Classic TSC, you're watching. Thank you so much. Muaba Mike, you're watching. Thank you so much for watching, guys. All right. So let us look at question number 4. Question number 4. All right. So question number 4A. Question number 4A. The question is, solve the equation 2x squared is equal to 6x plus 3, giving your answers correct to 2 decimal places. So we have the equation 2x squared is equal to 6x plus 3. So I'll call this equation as equation 1. Now when you look at equation 1 is a quadratic expression because the highest degree is a 2. Okay, because highest degree is a 2. So this is a quadratic expression. So I'm going to express equation 1 in the form ax squared plus bx plus c is equal to 0. So what we are going to have is that from equation 1 we will have 2x squared minus 6x minus 3 is equal to 0. We call this as equation 2. Now comparing equation 2 with a general expression of a quadratic, you realize that you have a will be equal to 2, then b is minus 6, and c is equal to negative 3. Now when you look at equation number 2, equation number 2 cannot be factorized using factorization method. We cannot solve it using factorization method. Okay? Why? Because when you find the product of a and c, which is 2 multiplied by negative 3, you have negative 6. When you look at 2 factors of 6, those 2 factors of 6 that can be added to get minus 6, and when we multiply them we get minus 6. We don't really have such factors, so we are going to use the quadratic formula. Okay, now the quadratic formula states that x will be equal to negative, positive or negative root of b squared minus 4ac over 2ac. The radical, which is the term under the square root, is called a discriminant, and it can be used to find the nature of roots in a quadratic equation. So substituting the values of a, b and c in the equation, we will get negative, the value of b is negative 6, so we'll have minus 6, positive or negative, then minus 6 squared minus 4. Our value of a is positive 2, so we write 2 there. Then our value of c, that is negative 3, so negative 3. Then divide everything by 2, multiplied by the value of a is 2, so we get that. So simplifying this, we'll get positive 6, okay, because negative times negative is positive, so you can say positive 6 or just write 6. Then positive or negative, the radical here will have negative 6 raised to the power 2, that will give us positive 36. Then minus 4 multiplied by minus 3, you get positive 12. Positive 12 multiplied by 2, you get positive 24. So we have positive 24. Then over 2 times 2, we get 4. Then simplifying this further, we have 6 plus or minus 36 plus 24. This will give us 60. Okay. Then over 4. Now, we'll call this 3. Now, when you look at equation number 3, by implication, x will be equal to 6 plus root of 16 over 4, or x is equal to 6 minus root of 60 over 4. So when you simplify this, you realize that the value of x will be 3.44. That is in 3 significant figures, and then the other one, the value of x will be negative 3.44. Okay, so this is in 2 decimal places, and that is also in 2 decimal places, because in the question they have actually told us to give the answers correct to 2 decimal places. So we have 2 decimal places on the first answer, and also 2 decimal places in the second answer. Therefore, we conclude that the value of x is equal to 3.44, or x is equal to negative 0.44 as your final solution. Alright, so that is how you work out this kind of equation under quadratic equations. When you see that a question or an expression cannot be factorized using factorization method, then it simply means that we are using completing of the square method or just the quadratic formula. All right, so we go to part B of question number 4, which is talking about mensuration. So this question is from the topic called mensuration. So the figure below is a frustrum of a cone. The base diameter and the top diameter are 42 centimeters and 14 centimeters respectively, while the height is 20 centimeters. Take pi as a 3.142. So calculate its volume. So we have been given a frustrum. Now, what is a frustrum? Let's consider a situation where we have been given a cone. We have a cone. Okay, we have this cone. So when I cut this cone somewhere here at that particular point, I will remain with something like that. Okay, something like that. So this here is what we call a frustrum of a cone. It's a situation where you cut a cone. So the remaining part is what you are calling as a frustrum of a cone. So in this case, we have been given a frustrum of a cone and we are asked to calculate its volume. So we will imagine that we'll have a full cone in this case. So let's say we have a cone like that. Then the diameter of this cone is 42 centimeters. Then we have a point here. We have the diameter of that point, which is 14 centimeters. Then the distance from this point to that point, this one, it is 20 centimeters. Then we know that we'll have from this apex of the cone, let me use a different color. Okay, from the point, from the apex of the cone to the center of the cone at the base there, we have the distance from here to the apex. Let's call it x. We don't know it. We only know the distance from that point to that point, which is 20 centimeters. So implying that the distance of a full cone, which is the distance from there up to that point, we don't know it. We'll just call it x, implying that the full distance or the total distance of a cone will be 20 centimeters plus x centimeters. So how can we find the value of x? We'll take ratios of height to radius or height to diameter and then find the value of x. So when you look at the ratio from a smaller cone, we have this one, this part here. This is a small cone. It looks like this. So we have the diameter, which is 14, and the height of this cone is not known. We have x centimeters. So taking ratios of the two cones, we are going to have x, which is the ratio of height to radius. So when I divide the diameter by 2, I will get 7. We'll have 7. And then the height, which is the perpendicular height of a full cone, will be 20. Let me say this is x centimeters, so we'll have 20 centimeters plus x centimeter over the diameter or the radius, which is 21. So solving for x, we are going to have 21x centimeters, which is equal to 7 multiplied by 20 centimeters plus x centimeters, like that. So we'll have 21x centimeters, which is equal to 7 multiplied by 20, we get 140 centimeter plus 7x centimeter. All right. So making or collecting the like terms, we'll have 21x centimeter minus 7x centimeters minus equals 140 centimeters. Then we can say 21x minus 7x, this will give us 14x centimeters. Then it will be equal to 140 centimeters. So dividing both sides by 14x, dividing both sides by 14 centimeters, we'll get the value of x as 140 centimeters divided by 14 centimeters. All right. So we'll have our value of x as 10. Okay. So the value of x is 10 centimeters. All right. Now that we have the value of x, which is 10, okay, we have the value of x, which is 10 centimeters. Now for us to find the volume of a frustrum, first of all, we need to find the volume of a smaller cone, which is the upper part. Then we find the volume of a full cone. Then subtract volume of a smaller cone from the volume of a full cone. Then we can find the volume of a frustrum of a cone. So how do you find volume of a cone? Volume of a cone is given by 1 over 3 pi r squared h, where h is the height, r is the radius, and you have pi, which is equal to 3.142 in this case. So let's call volume of a smaller cone, we call it as V1. So V1 will be equal to 1 over 3 multiplied by 3.142. Then the radius of a smaller cone is 7 because the diameter is 14. So you divide the diameter by 2 to get the radius. So you have 7 centimeters squared. Then our height, which is 10 centimeters. Okay? So when you simplify this one, you get, when you multiply 7 squared, which is 49, by 3.142 by 10, you get 1539.58 cubic centimeter over 3, and you get your answer 513.19333 cubic centimeter. So let's find volume of a full cone. Volume of a full cone, we'll call it as V2. So we have 1 over 3. Then our pi is 3.142 and the radius is 21. We raise it to the power 2. And now the height of a cone is 20 plus 10, which gives us 30. So we have 30 centimeters. Okay, we have 30 centimeters. So let me just write this properly. We have that squared, then we have 30 centimeters. Okay, so when you simplify this, you get 8.66 cubic centimeters over 3, and you get your answer 13856.22 cubic centimeter. So volume of a frustrum, we'll call it as V2, will be given by, we'll call it as V3, will be given by V2 minus V1. And so when you subtract V1 from V2, you simply get V2 is 13856.22 cubic centimeter minus 513.19333 333 cubic centimeters. Okay, cubic centimeter. So the final answer will be 13343.03 cubic centimeters as the final answer, which is the volume of a frustrum. All right, guys, so that is how you find that question. All right, guys, so this is how far we go for today. It's been a pleasure revising with you guys. Thank you so much for loving us and just for staying with us, guys. You really need to make sure that you study hard and make sure that you study smart as you prepare for your exam. Remember to leave your comments and questions. We will definitely look at the questions and your comments and get back to you in time. Once again, I am your presenter, By Kasonde, from Kafiwe Boys Secondary School. For now, it's bye-bye and stay yellow.